Today, let's talk about how to prove that a sequence is bounded. Sometimes the question will be, for example, to show that un is between 1 and 2, or it might just say show that the sequence is bounded. So we have 4 methods to prove that it's bounded. The method of induction, you already know it. For proof by induction, you do the base case, you do the inductive step, and you arrive at a conclusion. Just know that to prove it's bounded, for example, if it says to show it's less than 2 and greater than 1, you have to prove each part separately. If you try to do them both at once, you might get stuck. So you show that it's bounded above by 2, and then you show that it's bounded below by 1. So with proof by induction, we know what to do, we know how it's done. Then there's direct bounding. What is direct bounding? It's what we learned in first, second, and third year of middle school. The calculations we do for bounding. If this is greater than that, then this other thing is greater than that other thing. We already know all of this. We know, for example, that sine of x is between -1 and 1, and we know that cosine of x is between -1 and 1. If we have n greater than 1, that will give us 1 over n is less than 1. So we know all of that. For example, if we take a sequence equal to 3 plus sine of n, we know that sine of n will be between -1 and 1. So 3 plus sine of n will be between 2 and 4. So the sequence will be bounded above by 4 and bounded below by 2. So it's very simple, no problem there. And then there's studying the associated function. What is studying the associated function? For example, if we take a sequence, say un equals f of n, which is what we call being written explicitly, meaning un is a function of n. For example, if we find the general form of the sequence, we say it's written explicitly. When it's written as a function of n, we can take the function, consider it as f of x, and replace n with x. And we take this function and we study it. What does it mean to study a function? It means we find its derivative, what its value is, and we create a variation table. And we identify the global maximum and the global minimum. Then we can say the sequence is bounded by that global maximum and that global minimum. So there's nothing to it. The fourth method is to use convergence, because we have a theorem that tells us what? Every convergent sequence is bounded. This theorem might be beyond the level of the second year of high school. The teacher might not consider it correct. But every convergent sequence is bounded. But don't use it because the teacher might not like it.